let's take a look at situations where you don't have z-scores and you have actual scores. So we have some options here. We'll show you one conceptual option, and then we'll show you how to do this with the calculator. And so let's go back to looking at values that are normally distributed. Mean is 68, standard deviation is 5.5. And so the data, right, we don't have all the data, I just know what its mean and standard deviation is, and I know that it's normally distributed, so it's going to follow that form. And so then we know we can answer a question like this: what percentage of students passed the tests if the professor stated that 60 was a passing score? And so we could answer that question without even knowing all of the what the data is, just knowing that it's normally distributed. You find the z-score, right? What's the probability that your x-score is greater than or equal to 60? Is really like finding the probability that z is greater than or equal to some value. So what we do is we convert the 60 into a z-score, and then you calculate the probability that z is greater than or equal to negative 1.455, and you get that answer, which we know how to do from the previous video. So that's one option, is to convert these to z-scores and then calculate using the normal distribution, the standard normal distribution with mean of 0, standard deviation of 1. There's another method we can use, is using technology. So let's look at a same thing, but using without the conversion to z-scores. And so looking at a problem. Sorry, there we go. Let's get it in. Looking at this one here. The U.S. Navy requires fighter pilots to have weights of 62 to 70, have heights of 62 inches to 78 inches. What percentage of women meet this requirement? I don't know what's happening here. What percent of women meet this requirement? Here's the answer. What we're really doing is what proportion, what's the probability that a woman is between 62 and 78. We know heights are normally distributed in the world, meaning that if you collected the data of heights in women, it would follow this form. We would know it has a mean and standard deviation. So what we do is we calculate that there. So I need the 68.38 and 2.6. So what you do is for ARTISTAT, you're going to put in 63.8 here. Standard deviation was, let's go back, standard deviation was 2.6, and then we do the between, and we want it between, it said between 62 and 78, and so this will give us the percentage or proportion of women that fall between that, between 62 and 78, given this condition here. And it looks like our answer would be 0.75, or 75% of women would fall between that. And so there's your answer right there. You can get it. You could see here, this is the distribution of all women. Again, going back to StatCrunch, normal distribution, you're going to put 63.8, and we want the between one, and I think it was 2.6. You put 2.6 here, and then we want it between 62 and 78. Compute, and there it is again too. There's your normal distribution. I like that it's done by standard deviation. You click that, you could see the actual standard deviations, but it still doesn't change the answer. There's your answer right there. As you look at, these are all the women that fit between 62 and 78, the percentage of them. And so that's how you would do using technology to get it using StatCrunch. You don't need to convert to z-scores. What the probability that a man does not meet the requirement, so that's that the man is greater than 78 or less than 62. And so in that case, you're going to plug in those numbers here into the technology to get that answer right there. So you want to check to see you can do that. And then again, same thing. You have a mean of 5.5, 7.5, mean of 5.5, standard deviation. Let's repeat that. A baby weighing less than 5.5 pounds, you have the mean and you have the standard deviation, right? So we know that it's normally distributed. The mean is 7.5, standard deviation 1.4, and then we would use StatCrunch or the ARTISTAT to get us to this answer here. And again, you want to make sure we do that. Sometimes, and we're going to end this one here. Let's see. Let's finish this here. No, I should stop that right now, and then we'll do a video for the next one here.